Hello, Algebra Scholars. Section 4.1 is all about exponents and their properties, as the title would indicate. And there are a lot of different properties that we need to study in this section. None of them are too difficult, but one of the first things you have to understand before we talk about any of the properties is being able to identify the base and being able to identify the exponent. Sounds pretty easy, right? If you're talking about something like x cubed, well, that's pretty easy. The base is x, and the exponent is just 3. Maybe we'll make a little chart here like this, base and exponent. So if we had something, though, like 2x cubed, the base is still x, and the exponent is still 3. The 3 in the exponent isn't attached to the 2 at all. Some students find it helpful to put a multiplication sign in between a coefficient and a variable like that. However, if we had something like this, 4x to the 5th, well, then the base of that is 4x, and the exponent is 5. If we had something like x plus y squared, be careful here, the base is just y for the exponent 2. But if we do this with parentheses, 2x plus 3y to the 4th with parentheses, well, then the base is 2x plus 3y, and the exponent is 4. So knowing the difference between the base and the exponent, paying close attention to parentheses, super important in this section. Now, on to some properties. Okay, our first two properties are 0 as an exponent and 1 as an exponent. We'll do 0 as an exponent first. Our rule says this: anything to the 0 power in math is defined to be 1, except, there's one exception, except 0 to the 0, which is undefined. Anything else to the 0 power is 1. So we could have 4x to the 0 power, and that's 1. We could have 2x plus 3y to the 0 power, and that's 1. We could have anything to the 0 power, and it's 1. But like we said in the previous slide, be careful with your parentheses. Because if we have 2x to the 0, that is actually equal to 2. Because it's 2 times x to the 0. The base is x, and the exponent is 0. So this becomes 2 times 1, which is 2. So it's not a hard rule, but you have to be careful. You have to pay attention to the parentheses, and you have to know the one exception. 1 as an exponent is super easy. Anything to the first power is itself. So we could have, using some of the same examples from before, 4x to the first power, well, that's just 4x. 2x plus 3y to the first power is just 2x plus 3y. 3x squared y cubed all to the first power is just 3x squared y cubed. So those are pretty easy rules. On to the next ones. The next two rules are called the product rule and the quotient rule. We'll do them together because they're similar. The product rule says if you are multiplying two terms that have the same base, you keep the base and you add the exponents. And it's really important when you learn these two rules that you always remember this part of the rule. Keep the base and add the exponents. Many students, when they learn this rule, they just remember, oh, I'm supposed to add the exponents, and they forget what they're supposed to do with the bases. So anytime you say the product rule, it's important to say the whole product rule, which is keep the base, add the exponents. So that if we are doing 2x to the third times 2x to the fourth, we know to keep the base 2x and add the exponents and get 7. If we have x to the 5th times x to the 6th times x, we actually end up with x to the 12th, because we have to the 5th to the 6th, and this is actually x to the 1st. Okay, so a relatively straightforward rule there. Quotient rule, if you are dividing two terms that have the same base, like so, we keep the base and we, you guessed it, subtract the exponents. So once again, don't forget the whole rule, which says keep the base and subtract the exponents. So for example, we might have something like x to the 5th over x to the 2nd. That becomes x to the 3rd, 5 minus 2. We might have x plus y to the 10th divided by x plus y to the 2nd. We're going to keep the base, and we're going to subtract the exponents and get x plus y to the 8th. The power rule, which is our next rule, states that if you have a single base raised to a power, and then that whole term is raised to another power, you keep the base, and now we're going to multiply the exponents. So it's a single base a raised to a power, and then that whole term is raised to another power. So for example, if we have x squared to the 7th, we have x to the 14th power. If we have y to the 3rd to the 8th, we have y to the 24th power. Now don't confuse this with the product rule, which says if you have y to the 3rd times y to the 8th, that's very different. We have y to the 11th. In this example, we're multiplying two terms that have the same base, so we're keeping the base and adding the exponents. Here we have a single base raised to an exponent, raised to an exponent. We're keeping the base and multiplying the exponents. And our last two rules we'll do together as well, because they're very similar: product to a power and a quotient to a power. Product to a power says if you have a product inside a set of parentheses with an exponent on the outside, then the exponent belongs to each one of the factors of that product. So AB all to the nth power means a to the n times b to the n. And then of course the same is true if you have a quotient raised to a power. A divided by b all to the nth power. The power belongs to both the numerator and to the denominator. So a couple of quick examples. If we have x squared y cubed to the 4th, that really means we have x squared to the 4th and we have y cubed to the 4th. And now we need to go back to the power rule from the previous slide. If we have an exponent raised to an exponent, we multiply the exponents, keep the base and multiply the exponents. And then the same is true here. We have y to the 12th power. Now where students sometimes forget this rule is if there's a coefficient in there, like this. If we have 2xy cubed to the 2nd, that exponent 2, there is actually three different factors in here. So we end up with 2 squared, x squared, and then y cubed squared. So the final answer here would actually be 4x squared y to the 6th. And then with quotients, it's just the same as well. So if we have x cubed divided by y to the 4th squared, the exponent squared belongs to the x cubed, and it also belongs to the y to the 4th. So what we end up with is x to the 6th, using our power rule, divided by y to the 8th. And then, of course, there are lots and lots of examples that combine all of these properties together. So it's important to learn them well and practice a lot with them.